In today's lesson, we are going to look at one more example of quadratic inequalities, but this one is a little bit different from our previous lesson. So here we have x squared minus 6x plus 9 is greater than 0. So we want to know where is the parabola above the x-axis. Now, there's two things that we have to remember. When we have a quadratic equation or inequality, we have to move all the terms to one side. Now, luckily for us, all the terms are on the left side. So we also then go and look at this coefficient in front of the x squared, and we make sure that this coefficient is positive. Now we've got a positive 1 here, so we can already go and draw our parabola with its legs pointing up and the x-axis that is drawn through it. Then we go and factorize this inequality, and we get x minus 3 in brackets and x minus 3 in brackets is greater than 0. Now, as you can see, we get two of the same answers, which means that this quadratic expression is a complete square because it gave us two exactly the same brackets. Now, if we go and rewrite this, we can write it as x minus 3 in brackets squared is greater than 0. So if we want to go and get the critical points, we know what makes this bracket a 0 if x is equal to 3, and what makes this bracket a 0 if x is equal to 3. So we've got two exactly the same answers. So we cannot say that this x-intercept is a 3 and this one is also a 3, because how can it be a 3 in two different places? So that means when we get two critical points that's exactly the same, we need to move this parabola up so that it touches the x-axis only at one place. And that place is now the 3, which is the critical point for this bracket and this one. Got it? Okay. Now we want to know, where is the parabola above the x-axis? So it is above the x-axis everywhere. Do you see? Even if I go to the right, the parabola will be up here somewhere. And if I go to the left, it will be up here somewhere. So everywhere for all my x values, the parabola will always be above the x-axis. So we write that as x is an element of all real numbers, but then we have to go and make sure, is it just above the x-axis or does it include the x-axis? So it doesn't include the x-axis, so it touches the x-axis only at one point, which is at this critical point, which is 3. So we have to say x cannot be equal to 3, because we just want to know where is it above the x-axis. We don't want to know where it's equal to the x-axis. So this will be our answer. I hope you could follow, and see you again soon. Bye.